Students. So in these today's sessions, we're going to learn Logarithm. It's like 9th standard topic as well as in the 11th standard. Okay? So you all can enjoy. I'll try to cover all the basics of logarithm. What exactly is logarithm? Where exactly logarithm is used in mathematics? How it is important to in mathematics, how it makes simplifies calculation skills without using calculator, how fast you can do the calculations. All many things can be done with the logarithmic function. So we'll try and cover the basic things. Hopefully there will be 3 4 videos. We'll try to make it so that most of the stuffs I can put it in these videos. Okay, let's begin with our basic time. What exactly is logarithm? Say suppose this is like say uh, 10 power 2 is, let's say, it's 100. First of all, let's understand how to convert the log statement, the indices statement to the log statement. This is called as indices. And we are converting that into the logarithmic form. So look, this is called as base, this is index, and this is answer. Let's say. Okay? So we will say log of, let's say, 100, log of 100 to the base 10 is equal to 2. You understood? What is log? Log is basically this power. So log of 100 to the base 10 is equal to 2. Now what is things to this over here? Whatever is the answer comes over here. Whatever is the base remain the base. And the power goes as an answer. Okay, let's do one more example so that you can understand. Let's say 5 cube is, let's say, 125. Okay, it's 125. Now, how you going to convert that into the log form? See, 5 cube is equal to 125. So 125 is the answer. So log of 125. Keep writing this. Log of 125 to the base. What is the base over here? 5. How we read is log 125 to the base 5 is equal to 3. Is equal to 3. I hope you understood this. Let's do one more example. So hopefully you finish writing this in your book. If you have not finished, just pause the video and finish it. Okay, say suppose if it is 4 raised to power minus 2. 4 raised to power minus 2 will become 1 upon 60. I'm purposely trying to take one negative powers fraction answer so that you can easily understand how to convert it into the log statement. Now look at this. The answer comes as a log. So log of 1 upon 16, log of 1 upon 16 to the base. What is the base over here? The base 4. The base 4 is equals to negative minus 2. Is equals to negative minus 2. So it could be anything. Now let's learn. I hope you understood how to convert these indices to the log. So the next part will be converting the log to the indices. Okay. So you can pause the video, copy paste this all the 3 statements, and then let's move ahead. Now you are going to learn, student, how to convert the log statement to the indices statement. So how to convert log into indices, guys? Look at this. This is the example. This is example number 1, example number 2. We'll do 3 examples. Okay. So I'll just write over here log 0.125 to the base 8 is equals to minus 1. Now, how to convert these into the indices form? Very simple. It's very simple. Look at this. We'll write first of all the base, and then we'll write it down. The power is minus 1. 8 power minus 1 is equal to 0.1. You understood how to convert this log into indices? Very simple, isn't it? Now we'll take one other example. Log. I hope you finished writing this. 0.01. 0.01 to the base 10, to the base 10 is equals to minus 2. Say along with me these guys. Log, say along with me, log 0.01 to the base 10 is equal to minus 2. You understand how to read this? Read along with me. Again, log 0.01 to the base 10 is equal to minus 2. Very good. That's nice. If you have said it, perfectly. That's nice. Now, how to convert these into the indices form? Come on, you can pause the video and finish it off. So it will become 10 power minus 2 is equal to 0.01. Hopefully you got that right. Isn't it nice? Okay, let's try one another sum. Say, look at this. This is something as a log 1 to the base 10 is always equals to 0. Okay, now how to convert these into the indices form? Okay, you want to read it once again? Read it. Log 1 to the base 10 is equal to 0. Did you understand how to read this? Let's try it once again. Log 1 to the base 10 is equal to 0. You understood? Now, you can pause again the video and try solving this. Come on, hurry up. 10 power 0 is equals to 1. So simple. The base power the answer is equals to this one. I hope you understood this. Isn't it nice? So simple, isn't it? So pause the video and copy paste in case if you have not done something. Now, student, if you notice, see there are three things. Something is base. Okay, I'll just do over here. Something is like 1 and 0 and 10. There are three values. So now the next step of the question is out of that three, one, two, three, out of that three things, any two would be given and the third one you will be asked. So out of two things, like out of three things, two are given, then third one how to find? I'll just teach you so that you can do this. Okay, so the question says find the missing x. Find missing x. Now, how to do this? Okay, let's read this third type of question. Say log of 0.125 to the base 2 is equal to x. You understood? Now, what is supposed to find the value? How are you going to do this? Simple. 2 power x is equal to 0.125. Convert this log statement into indices statement. Log to indices, okay? Now it's very simple. Now it's really simple. This will become 2 power x is equals to, this will become 1 upon 8. Basically, okay, you don't know how. It's simple. 125 upon 1000, which will become 1s are and 8s are. Isn't it? How it is 1 upon 8? And now it will become 2 power x is equal to 1 upon 2 power 3. Now it does it will go up and it will become 2 power minus 3. Isn't it? This will become 2 power minus 3. Now if we compare 2 power x is equal to 2 power minus 3, then you'll understand the value of x, is equal to minus 3 because bases are same, so we can compare the powers. So x is equals to minus 3. Did you understand this? This is super duper easy. Isn't it nice? Show thumbs up. I hope you liked it. Isn't it? Now we'll take one more example. The example will be the same, just different values. Okay. Example number 2. Now log of, okay, I am putting x over here and 2 over here, and over here I am putting, what is that, minus 3. So what is the value of x? That's what is supposed to find. Now how are you going to do this? I'll just try to solve one question on the page. Now, how will begin? Again, convert this log into indices form. How to convert this log into indices form? 2, look at this. This base will remain base, power minus 3. Power minus 3 is equal to x. Now 2 power minus 3 will become 1 upon 2 power 3 is equal to x. So x is equals to 1 by, what is 2 power 3? 8. Now 1 by 8 can be written as 0.125 also, isn't it? So you write any of these answers. X is equal to 1 by 8, x is equal to 0.125. Now it's very simple, guys. Sometimes they'll give the fraction answer, sometimes they'll give the decimal answer. Isn't it so simple? I hope you understood this. Okay, I'll take a third variation. What will be the third variation? The third variation that x could be over here. So log of 0.125 to the base x is equal to minus 3. Now how are you going to do this? How are you going to do this? See, simply, first of all, we'll convert that into the log to indices form. How to convert that into indices form? X power of minus 3. X power will become minus 3. The base raised to power the answer is equal to 0.125. 0.125. Now it becomes little tricky when people don't know how to play with the indices and the decimal. So it's simple. Basically, it's really simple. So we can convert this x power negative 3 is equal to 1 by 8. 1 by 8 can be written as 1 upon 2 power 3. And you can take it up. X power negative 3 is equal to 2 power negative 3. Are you understanding how at a time it can become a little tricky? So now look at this. If the powers are same, we can equate the bases. This is very simple indices rules. So what happened at a time people don't know the decimal and they don't know the indices rule. And then that's how this log become for some people little tricky chapter. Otherwise it's super duper simple. So x is equal to 2 because the powers are same, so the basis has to be equal. So this is how we're going to get the value of x is equal to 2. Now if I minimize the screen, you'll understand all the three things, like what I spoke just before I started this topic, how to find the missing x. So there are three variables, 1, 2 and 3. So देखो first case में यहाँ पर x था, second case में the answer was x, and in third case the base was x. So do any method, the answers are same, isn't it? Answers are same in the sense like it is 2 in all the cases. It is 0.125 in all the cases, and it is minus 3 in all the cases. Did you notice? So this is what I was trying to tell you guys. So find missing x can be in any form. So you don't have to worry. Just convert that into the indices form. Then apply the law of, indices basic rules, and you're going to get the value of x. I hope you understood how to find the missing x though. Anyone has doubt? Please raise your hand. Okay, students. Now what we're going to do, we're going to learn some laws of the logarithm. So what are the laws of logarithm? Keep writing, guys. One second. Hold on. Let's learn something called as laws of the logarithm. Keep writing, guys. The laws of logarithm, guys. First law. There are on an average 5 to 6 laws. So first one is called as product law. Log AB is, suppose if you have something as log A into B, then we can write that as log A plus log B. So log AB can be written as log A plus log B, or vice versa. If something is written as log A plus log B, we can write it in that as log A. Let's say let me give the example. Example could be something like this way. Log say log 10. So it can be written as log 2 into 5. That can be written as log 2 plus log 5. Now you must be wondering, sir, where is that base has come? So when there is no base, that means there is 10. Remember that when there is no base, that means there is 10. And if there is some base, then that is to be written over here, like 3 or 5 or something like that. Okay? So when there is no base, then there is 10. You have to remember that. Okay. Next law, log A upon B. The first law is called as product law. The second law is called as quotient law, because A upon B. So that would be nothing but log A minus log B. Again, so when it's a division, it's a repetitive subtraction, so it's minus. I hope you understood that. And third law is, for the example, log of 10. It can be written as log of, say, log of 20 upon 2. So we'll write it down that as log 20 minus log 2. I hope you understood. These are just an example, okay? This will be the example. Third one, log A power m can be written as n log A. Example, log of 4 square. So that can be written as 2 log 4. Whatever is the power goes outside this. always equals to 1. Log of a to the base a is always equals to 1. Like log 10 to the base 10, log 10 to the base 10 is always equals to 1. If you want, you can just take it out x. You can do 10 power x is equal to 10 power 1. So x is equal to 1, isn't it? So x is equal to 1. So you can take anything. Whenever the base, like log a to the base a is always equals to 1. Then the fifth law, log a to the base b can be done as log a upon log b. What do you mean by that? This is very, very important, guys. It's a very important law. Log a to the base b can be done as log a upon log b. Say, suppose log 10 to the base 2 here. So we can write it on that. Log 10 to the base 2 can be done as log 10 upon log 2. I hope you understood this till here everything. Now sixth one, which is very, 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 very important. So what is this law? One second. Let me just sixth law is log a to the base b. If it's written as like this, then it can be written as 1 upon log b to the base a. Or it can be also written as log a upon b, or log a to the base b into log b to the base a is always equals to 1. This can be also written as same thing, it's just in the different format. Log a to the base b into log b to the base a is always equals to 1. I hope you understood. This is just this, you take this term on the other side and then it becomes this kind of one. I hope you understood till here perfect. Now the seventh one, which is super duper easy and important one. Okay, so it is a. Now understand, this is in the power. A power log mn to the base if it's a. Okay, a's power is log mn to the base a. Then it's simply written as mn. Okay, this is log a power log mn to the base a is always mn. Okay, now there are many more rules such like it's simply written as like eighth one. These are all like byproducts basically. A power log m to the base a plus a power log n to the base a. Now what can be written as, see, simply this will become m and this will become n. So this becomes m plus n. Are you getting it? So you have to just look very carefully. A power log n to the base a, that means just n. A power log n to the base a, that means simply n. So this will become n plus n. You understand? So there are such, all the rules can be applied, like the subtraction one or the product one. All the rules can be applied over here. Like I'll just use one and then I just show. A power log n power n to the base a. So it can be simply written as n power n, isn't it? Or if it is n is outside, that also can be written as in this form. I hope you understood what I mean. Now, very important thing is what? The constant, the log constants. Log constants. Now, what are the log constant? Look at this. Log 10 is always equal to 1. Let me just put it here. Log 10 is always 1. Log 100 is always 2. Log 100 is 2. I can write the log 1 is 0. See, now did you notice something? Log 1 is 0. Log 10 is 1. It's 10 power 1. It's 10 power 0. It's 10 power 2. Are you understanding? There is nothing, that means there is 10. When there is no base means base is 10. If log is without base, that means base is 10. Log no base means base is 10. Okay, remember that. Now if we take it out something like this, log 1000 will be 3 because 10 power 3 is 1000. Log 1 lakh will become 5 because there are 5, isn't it? Now understand. So if I do log of 0.1, what will happen? This is 10 power minus 1. Log of 0.02. It's not okay, 0.02 later. 0.01. Then it's minus 2 because 10 power minus 2 is 0.01, isn't it? So on, guys. I hope you understood all these constants. Now, if you have understood all these things, guys, you can do any sums based on this. So I hope you finished writing the laws as well as the all constant, isn't it? So these were all the laws of the logarithm. And if you have understood this, it's really nice. If someone wants any repetition, please ask. I'll repeat it for you. So please pause the video over here and copy paste this, guys. It's really, really important, guys. So laws of logarithm, product law, quotient law, power law. Then fourth one, fifth one, and sixth one are like the basic ones. Log a to the base a is 1, log a to the base b is log a upon log b. Then the sixth one is log a to the base b is equal to 1 upon log b to the base a. You can take it on other side as equals to 1. And then the seventh and eighth one, like a power log m into the base h can be written as simply mn. So these are very important. Many sums I have seen on the basis of this law in the many competitive examinations. So you should be very clear with this law. And then finally, what are the constants? So these are the constants of the logarithm. Like log 1 is 0, log 10 is 1, log 100 is 2. I hope you understood. I have very nicely summarized this chapter. So in the next part of the video, guys, what we're going to do, we're going to do plenty of sums. Okay, we're going to do plenty of sums. So see you in the next video. Till then,